Welcome to Mr. Source tutorial. Before we proceed with the theorem of analysis, we are going to first of all look at a very important topic in circuit analysis, which you cannot do without as far as circuit analysis is concerned, which is the series and parallel resistance circuit. Okay, now we are going to be looking at its effects and characteristics, and also a problem application of this connection. But you're going to be starting with the series connection. Okay, most students have problem in solving and identifying the series and parallel resistance in the circuit. At the end of this video, such problem is going to be solved, as we are going to take time to analyze and explain each step of arriving to such. Alright, it can be connected in a parallel, it can be connected in a series. Alright, whichever way, is good for us to understand how to find equivalent or total resistance in the circuit, just as what we have here. This is what we are going to be doing. Okay, but you have to know what we mean by a parallel connection and what we mean by a series connection. Okay, take for instance, this is a resistor. This is head by H. Alright, and call this is tail by T. Okay, the same thing, call this is head, just like head by H, just like head of something, and call this is tail by T. Alright, now when the resistor is connected tail to head, when the resistor is connected head to tail, alright, head to tail, that is known as a series connection. Like if it's connected like this, you can continue as many resistance as possible. Alright, so you have a two possible terminal like this form, okay, it's known as a series connection. But when you have two resistance like in this form, R1, in this form, call this R2, and this is his head, tail, this is his head, this head, alright, and tail. When it's connected like this in this form, head to head and tail to tail, bringing out two possible terminal like this is known as a parallel connection. Okay, alright, in this circuit I can see the resistance are connected. This is the head, this is the tail. The tail of resistor R1 is connected to the head of resistor R2. Okay, the tail of resistor R2 is connected to the head of resistor R3. Alright, you can continue as many resistance as possible. That is what we know as a series connection. Alright, now for us to have a total resistance at this terminal AB, which also equals to resistance AB, or it can also be called equivalent resistance. For us to have a total resistance of this circuit in series circuit, you're going to have that RT is equal to R1 plus R2, because it's connected head to tail to head to tail. Alright, because it's connected head to tail, R1 plus R2 plus R3. Alright, it will continue to plus R of n, which is this R of n. Alright, this means that you can continue to as many as possible. You can continue even if it's connected, as far as it's connected tail to head, tail to head, tail to head, you can continue to infinity. Okay, that's the formula of finding total resistance in series. Alright, okay, as you can see in this circuit, the same current is flowing through the closed loop, the closed path. Alright, which implies that the current that is flowing through resistor R1 will flow through all the resistors in the circuit. Alright, but the voltage drop at each resistor is different. Alright, while the current is the same. That's one of the characteristics of a series connection. Now let's move into parallel connection. As you can see, in parallel connection, these resistors are connected head to each other. They're tying head to each other, head to each other. You can continue to any number of resistance as possible. Alright, for us to find the equivalent or total resistance at this terminal, for us to find the R total now, okay, when you are dealing with series connection, you can see how the thing was. And R total in this resistance is given as 1 over R total, because it's inverse of series. Alright, this inverse be equals to 1 over R1 plus 1 over R2, this R2, plus 1 over R3, this R3. It can continue to 1 over Rn, which is here. Alright, there is no point of cramming formula, okay? But basically, if you have two resistance in parallel, that is, if you have 1 over R total equals to 1 over R1 plus 1 over R2. Alright, if you do the basic mathematics here, you find out that you're going to have 1 over R total equals to R2 plus R1 divided by R1, R2. Alright, so that your R total will be equal to R1, R2 divided by R1 plus R2. Okay, this some textbook or some text might be showing this for formula or finding the resistance, two resistance in parallel. Okay, you can derive the same formula for finding two resistance in series, but this is the basic formula that you use. It's the same thing all through together, right? The same thing all through together. We don't need to cram this formula. As far as you understand this concept, you can find your total resistance as what you're going to do in the video. Okay, let's consider this example. Alright, for series, the question says find the total resistance in the circuit below. Hence, determine the circuit current. This is the circuit. What you need to do as usual, solution. Okay, this is what they're asking you to do, and this is how the circuit will look like. You have to determine this. Okay, you have to determine this value R total. Alright, this is 60 volt. Okay, and the current of this circuit here. Alright, so that's what you have to do. So what the value of this total resistance is what they ask. Okay, alright, as you can see in this circuit now, these resistors are connected head to tail. Right, so what you simply need to do for us to say your R total is going to be equals to 10 plus 7 plus 5, was connected in series, plus 8. What we did previously, that is going to give us R total equals to 30 ohm. Alright, some of this color is going to have 30 ohm. Okay, so the formula that our R total is given as 30 ohm. Alright, remember from Ohm's law that voltage V is given as IR. Alright, now therefore our I now will be equals to V over R, which is equal to 90 over 30. Alright, from this circuit. Okay, so now 90 over 30 will give us 3. The current I is equals to 3 ampere. Alright, a very simple example of a series connection of a circuit. Okay, So now let's go into the parallel example. Alright, in these parallel circuits, as you can see here, these resistors are connected head to head and tail to tail, which is a parallel connection. We have to find the question says find the total resistance on the circuit below. Hence, determine the current I of x, which is this is the I of x, which is the as I total. The current that is flowing to the network is what we are looking for. Okay, so what we are aiming at, what we are actually aiming at is for us to have something like this, plus minus 4 volts, and a single resistor, which is the total resistance. That's the point of this analysis. R total. This is what we are actually looking at, and now we have to find this current I of x. Okay. All right. What we said previously, it's very simple for us to solve. You don't need to cram formula. The thing is, the procedure is just simple. You can follow my step. It's a very simple step. All right. What you need to do is for you to read the formula for R total, as you look in is inverse of a series. It's going to be 1 over R total. All right. Equals to, you can call this your R1, call it your R2, and this is your R3. Okay. This is going to give us 1 over R1 plus 1 over R2 plus 1 over R3. Alright, which is equal to 1 over 2 plus 1 over 4 plus 1 over 2, where R1 is 2, R2 is 4, and R3 is 2. Okay, so we are going to have 1 over R total. 1 over 2 is 0.5, which is 0.5. Alright, plus 1 over 4 is 0.25, which is 0.25. Okay, plus 1 over 2 is 0.5. This is 0.5. Okay, all right, summing this together, 0.5 plus 0.25 plus 0.5, 1 over r total is going to give us 1.25. all right, now for us to find our r total, you cross multiply. Okay, so that our r total now will equal to 1 over 1.25. It therefore implies that our R total is equals to 0.8 ohm. Okay, and so therefore now our R total here is equals to 0.8 ohm. From Ohm's law, I of x is equal to 4 divided by 0.8. Okay, 4 divided by that is going to give us I of x is equals to 5 ampere. Alright, that is a simple method and a simple way of solving this type of problem.